Healthy forests provide a wide range of benefits. According to the U.S. Forest Service, America's forests sequester over 800 million tons of carbon per year, roughly 12% of the nation's annual emissions. These forests also provide drinking water for 1 out of every 2 people in the U.S. and support erosion and flood control, wildlife habitat, cultural resources, and abundant recreational opportunities. Many forests in the western U.S. evolved with regular fires, alongside indigenous peoples' stewardship practices that recognize fire as key to ecosystem health. The intensification of natural resource extraction, urban development, and fire suppression has altered forests and prevented regular low to moderate intensity fires that historically helped prevent the spread of insect and disease outbreaks. Today's high-severity wildfires and forest stressors, accelerated by a changing climate, are prompting land managers to take action.
To restore natural watershed processes in the face of these changes, we can use computer models to simulate the historical range of variability in forest structure under pre-Euro-American settlement conditions, with the assumption that natural disturbance in vegetation interacted to create and maintain a dynamic but resilient landscape. By using the simulation, we can gain an understanding of what the landscape vegetation patterns most likely look like, say, 150 or 300 years ago, and then we can compare that to current vegetation conditions to determine what we call current departure. This refers to the magnitude of differences in vegetation conditions between today's forest and the historical forest prior to major disruptions of natural processes by Euro-Americans. Most importantly, a current departure assessment allows us to identify where on the landscape and to what degree the forests of today differ from the forests of a few hundred years ago, and thereby help restoration efforts focus on repairing forests and watershed processes to reflect more dynamic natural functions. While we are looking at the data and seeing an illustration of what it's telling us the forest could have looked like, it's important to keep in mind that the data describes a range of variability and that this is just one example of what historic conditions most likely were.
The North Yuba Landscape Resilience Project is a landscape-scale forest restoration project in the 275,000-acre North Yuba River watershed on the Tahoe National Forest in California's northern Sierra Nevada. Improving forest resilience to drought and wildfire are top priorities. Our project team used the historic range of variability, referred to as HRV, and current departure data generated by Dr. Kevin McGarrigle and his team to characterize potential drought intensity and natural ecological function. We used the HRV and current departure data to identify and recommend priority treatment areas and specific restoration activities that will help set this landscape on a path to becoming more resilient to severe impacts from drought and wildfire. Proposed activities include forest thinning and prescribed fire to reduce forest fuels and stand densities and promote more resilient tree species composition while maintaining important wildlife habitat, particularly for species associated with mature and old forest ecosystems. Implementing these types of activities reduces the risk of wildfire climbing from the forest floor into the tree canopy and spreading. And it also reduces competition for water among the residual trees, making them more resistant to drought and insect infestations. Our work is designed to promote diversity in the sizes, ages, and species of trees, which support a broad array of native plants and animals, all of which is guided by the diversity of vegetation composition and structure exhibited under the historic range of variability. The Forest Service is planning to have a final decision on a portion of this landscape in the summer of 2023. This will allow us to begin implementing project activities this summer and into the fall.
This is one powerful example of how data and science can be used to increase forest resilience. We need to repeat this process in other regions to help save forests everywhere. We can be empowered to steward our forest commons. Join VP Data Commons in restoring forest ecosystems and reducing the risk of wildfire.